All right, Kelsey's commute is 15 minutes longer than Christina's. Do you know how long Christina's commute is?
Yeah.
Careful. Kelsey's commute is 15 minutes longer, right? So, okay, so you can view it that way, but we know everything we need to know about Kelsey, right? In that description, it says nothing about Christina, correct?
Well,
It says nothing about Christina, right? In that first sentence, doesn't say anything about her commute. No. And that's something that you want to kind of think about as you go through story problems in any algebra class or geometry class or whatever. When they start referencing two things against one another, here we're comparing Kelsey and Christina against one another, right? I know more information in this case about Kelsey. I know very, very little about Christine. Okay? I only know Christina's information in comparison or in use of Kelsey's information. Does that make sense, everybody? So Christina is the person or the object that I know the least amount of information about. When you're having this situation in story problems, when you are trying to decipher variables and stuff like that, you let the thing that you know the least amount of information about be your simplest variable. So what would our simple variable be here? If you don't know something, what do you let be? Usually x, right? Okay. So I'm actually going to let Christina's commute time be x here. So then if I know Christina's commute time is x, automatically know Kelsey's, right? Okay. Kelsey's commute time would be x plus 15. Okay. So that's kind of the way I think that's most appropriate here. If I keep reading, it says Christina drives 12 minutes for every 17 minutes Kelsey drives. All right. You guys know like key phrases when we see the words of or more than or less than. They tell you operations, right? When you see the phrase for every, they're telling you that is a ratio. Is that right? Okay. You guys, maybe are more familiar with things like, what does that stand for? Miles per hour. But another way of writing that is miles, blank miles, however many, for every 1 hour, right? So hours, right? Okay. So blank miles for every 1 hour is sending us miles per hour. The word per tells you ratio again, right? Okay. So those are key phrases that are going to be useful for you as we go through work with these story problems. So I've got 12 minutes for every 17 minutes. Okay. Now we could obviously put our units there, but minutes over minutes you're going to cancel out, right? So this is a pure ratio. Now I'm going to. I think it's a very, very good idea, guys, to organize your thoughts, organize what the 12 represented, what the 17 represented, so that you don't mess up the next ratio. The 12 was for Christina, right? And the 17 was for Kelsey. I just put little labels on the side. They don't mean anything for my ratios in regards to like algebraic calculations that we're going to do in a minute, but they're going to help me decide how I write this second fraction. And you guys told me that Christina, we didn't know her rate, correct? We didn't know how fast she was driving, or I guess the time that she was driving. Okay, so we let that be x, right? So where should x go? Should it be on top or should it be on the bottom? On top, right? Because going off of what we talked about yesterday, maybe when we started talking about figures, is that the numerators have to have a link between them, right? Okay, we talk about polygons. The numerators all came from the same shape, right? Let's view Christina as a shape, okay? Then the numerators have to be all the values that come or talk about Christina. Does that make sense? So if that's x, Kelsey's is going to be x plus 15. Okay. When I cross multiply, I get 12x plus, 10 times 15 is what? 115. So 2 times 15 is what? 30. So that's going to be 180, right? And then 17x. So 180 is equal to 5x. Okay, Cameron, 180 divided by 5. Come on, man. 100 divided by 5. Nickels and a dollar.
36. 20.
He answered the question, 180 divided by 5. 20 nickels and a dollar, right?
Yeah.
Okay, 16 nickels and 80 cents, right? Yeah. All right, 16 and 20 together equals 36. So x is 36. So that is Christina's time, right? Kelsey's time would be 15 more. It's going to be 51. Okay. Is that something we can do? All right. Now, some of you may have done this, which is fine. I don't know that reading the description that this would be a proportion that kind of jumps out at us. But we could do it this way. We would say 12 over x. Okay, now viewing straight down, that's all the information in regards to Christina. Does that make sense? Okay. So this ratio here would be everything in regards to Kelsey. Okay. Well, 12 was the, came from this 12 minutes, right? So the numerator would be 17 here. Does that make sense, everyone? And this would be x plus 15. What did we essentially do there from this one over here to gain this black one? Just flip-flop the what? Nope. What are those? We flip-flop those things, right?
The means.
The means. We flip-flop the means. And we know that that's something we're allowed to do, right? And for the reason that we could actually write these, I don't know if I could write these kind of backwards like that, okay? There's actually absolutely nothing wrong with flip-flopping the extremes, okay? Because if I look at this here, what if I flip-flop those? That would put x plus 15 on top, right? And then it would put 12 down here, which if I look at it this way, that would be flip-flopping the extremes in that format. Does that make sense for everybody? So flip-flopping the means, when we say you're allowed to flip-flop the means, we're ultimately saying you're allowed to flip-flop the extremes as well. So that would be another maybe proportion that would be developed. But I don't think any of those really would have been easily created from the description that's provided, in the way that's provided. We could have done this. Now, again, this isn't the most obvious thing to do because the word more or longer usually means what operation to us? Oh, it could be multiplication, okay? But I guess in this situation, just because of the way it's provided, we would probably mean addition, right? Okay, 15 minutes longer. So we're going to add that 15 minutes on. So that means, what if I would have done this? What if I would have said Kelsey's time was X? Now, Kelsey's was longer than Christina's. So what do I need to do to Christina's? I can subtract 15, can't I? Okay. Now what's going to happen there is we get 12x is equal to 17x minus 180. So it gives me negative 5x is equal to negative 180. Now what's x? Actually, I did some wrong work there, right? 17. What's 17 times 15? That's not right. 17 times 15, I still took 15 times 12. What's 10 times 15? 150, okay? What is 6 times 15? 90, okay? And then one more 15, right? Okay, so I think it's a little bit easier to do all that addition in your head in contrast to the multiplication. Just the way I deal with things. So that's 240, what, 255? Okay, so I get 255 here, okay? So now I'm going to get, what, negative 5x equals negative 255? Cameron, how many times does 5 go into 25? 5 times. And it's pure, strictly 5, right? So now how many times does 5 go into that 5? 1. So we got 51, right? But now what did x represent? It represented Kelsey's time. What's 51 minus 15?
36.
36, which represents Christina's time. Still exact same numbers that we came up with, right?
Yep.
Okay. How can I determine if I'm right with those two values? Can I take my calculator and type that out? Get a decimal. Okay, now it's going to probably be an ugly decimal because 17 is prime. Okay. But then shouldn't I get the same thing when I type 36 divided by 51? Get a decimal. If those two decimals are equal, I know that I have satisfied the requirements of this problem. And I've got the right values. Okay? Would you guys agree that when we go through that problem and compare it to maybe 38, where Sarah and Josh are working, okay, it says Sarah works 7 hours for every 2 hours that Josh works, but it says Sarah works 10 more hours than Josh. So I don't know what Josh worked, Sarah worked 10 plus that, right? Is that the same problem?
Yep.
Different context, right? Okay, different people, that kind of thing. They're working and not driving, but it's the exact same problem. Okay, would you guys agree that when I look at number 37, and I've got the Vikings leading the Timberwolves by 19, that's very similar to saying that somebody drove 15 minutes longer than somebody else, or somebody worked 10 hours longer than somebody else? Okay. Now they're saying the Vikings scored 3 points for every 2 points. Is that similar to saying that, one person drove for, 12 minutes for every 17? Or somebody worked 10 hours for every 4, something like that, 7 hours for every 2? So 3-2 is my ratio. The Vikings were winning at halftime by 19, so I don't know what the Timberwolves score was. The Timberwolves were the 2s, so I put them on there. And then you write that as X plus 19 up there. Does that kind of make sense? Same exact problem. So I was hoping you guys saw 37, 38, 39, and 40, changing the context. But if you understand how to do one of them, the hope is you click on all of them. Yeah, if you can't do one of them, then you're going to struggle with all of them. But that's kind of what happens a lot in mathematics courses is you get very